Time check, it's already 3 o'clock in the afternoon. Magandang hapon po mga iskolar ng bayan para sa bayan. And welcome to our physics webinar entitled Let's Get Physical, a webinar on appreciating concepts in physics. So good afternoon po sa ating lahat and thank you po for coming to our webinar. So my name is Joshua Michael Jonas. I'm the University Research Associate and Tutorials Coordinator of the UPLB Learning Resource Center, and I shall be your moderator for this session. So, kumusta po kayo guys? So, as of now, we have 110 viewers from our FB Live, although we had 936 registered participants for this webinar. So, magandang hapon po sa inyong lahat. So, how are you guys? So, I hope you're all doing good. So, we have participants all over the country from different constituent universities of the UP system, from UP Manila, Diliman, Mindanao, as well as other distinguished universities and colleges here in the Philippines. So welcome po. And I believe that all of you are very much excited to have this short but very concise review in physics and hopefully learn new things, new concepts from our distinguished speaker this afternoon. So on behalf of Team LRC, we would like to thank you for making it to our webinar. We know that many of you, dear students, as well as our faculty members, are struggling with the online learning setup, especially in understanding and coping up with very complex subjects such as biology, chemistry, mathematics, and of course, physics, which all we know, all of these subjects require extensive practice, review, and thorough discussions. So I firmly believe that this webinar will be helpful for our students, especially those who are taking up physics classes this semester. So learning under the new normal is indeed a challenge for all of us, brought by the many restrictions by COVID-19. Nevertheless, we still want to make these learning opportunities available for you in the safety of your own homes, continuously upholding our banner of honor and excellence. Okay. To proceed, here are a few reminders before we begin our session. First, please keep your comments helpful and respectful to our speaker, facilitators, and fellow participants. Second, please ask only relevant questions related to our topic after our speaker has finished discussing. Then lastly, please do not forget to answer the evaluation form after the session. Team LRC greatly appreciates your comments and suggestions for us to further improve our programs and services. Do take note, however, that only registered participants will be sent the link to the evaluation form in order to secure your e-certificate of participation. Okay? Let's use the hashtag Let's Get Physical so you can easily see our posts and videos regarding this webinar. Okay? And to those participants who won't be able to make it to our live session this afternoon, don't you worry. Well, because probably you have an equally important event and perhaps you have problems with your internet connection stability. So again, don't you worry, we heard you. We will have this recorded FB Live session available in our Facebook page as well as our YouTube channel. And speaking of which, kindly follow us, like and follow us and on our social media accounts at UPLB LRC on Facebook, Instagram, Twitter, and YouTube, so you can be updated with our future programs and webinars. You may also watch our previous episodes of our webinar series from our YouTube channel. And please don't forget to like, share, and subscribe. So as of now, we have 1,230 subscribers. So thank you so much, our dear teachers and students, and all of those who support our team here at LRC. Okay, now to formally start our session, may I call on our beloved director, Dr. Benjamina Paulo G. Flor, to give her opening remarks. Ma'am Benj, you now have the Zoom space.
Good afternoon, everyone, and thank you once again for gracing this webinar on physics. As you know, physics is one of the most difficult subjects, probably not only in high school or in college, but if you look at the practicality of it, well, they always say that these difficult subjects are are part of everyday life. And true enough, I think physics is one of the things that we do daily, and yet we do not appreciate or maybe notice the role that physics play in our daily activities. And so for this afternoon, we are very honored, humbled, and happy to have with us Prof. Dustin, who will share to us very practical and very important concepts and principles that you may need, especially in Physics 51. And so today, we are hopeful that you will have more time and appreciation on the content, not really on the speaker. I know I've read some of your comments when you registered. So I hope you focus on what Sir Dustin is going to say and not on Sir Dustin. Without much further ado, thank you so much, Sir Dustin. And I hope we'll have a fruitful and meaningful physical or physics conversation this afternoon.
Thank you so much po, Ma'am Benj, for your inspiring words for our dear participants. Okay, so let me just share my screen. All right. So let's now proceed to our session proper. We are just like what Ma'am Bench has said, we are very blessed to be graced with the presence of a physics expert all the way from Toronto, Canada. Yes, you heard it right. Our speaker right now is live in Canada. So I believe it's around 2 o'clock in the morning from Canada. So we are very blessed because our speaker did not sleep just to be with us in this webinar. So moving on, our speaker this afternoon took his bachelor's degree in applied physics here in the University of the Philippines, Los Baños. He finished his Master of Science in Physics at the De La Salle University, and he was a former research fellow at Kobe University in Japan. He was a former assistant professor at the Physics Division of the Institute of Mathematical Sciences and Physics here in UP Los Baños. At present, he is finishing his Doctor of Philosophy degree in Medical Biophysics at the Department of Medical Biophysics, University of Toronto in Canada. Ladies and gentlemen, allow me to present to you our distinguished speaker for this session, Mr. Dustin Loren V. Almanza. Sir Dustin, you now have the Zoom space.
Yeah, hello. Yeah, good afternoon to everyone, and thank you to UPLB LRC for inviting me. So yeah, I'll just first share my screen. Hello, can you guys see my screen? Okay. So again, good afternoon, and thank you again to UPLB LRC for inviting me this afternoon. Even though I'm far away, I'm really wanted to share. Basically, I'm not that expert, but I really wanted to share my experience in teaching physics classes while I'm still back in the university. So for this afternoon, I'll be having a quite short introduction on appreciating concepts in physics. So I really wanted this title since most of most of the most of the students have this barrier with physics. Like ma'am said a while ago, that really physics is one of the hardest subject that we usually take, not just in high school but until college. So the thing is, we really have to appreciate physics first before we can fully understand and maybe love it afterwards. So the outline of my presentation, I have just three parts. First part is I just want to share my experience as a teacher and as a student of physics. Second will be proceeding with thermodynamics, some short thermodynamics review. So we'll be focusing on the three laws of thermodynamics. And another topic that most of the students requested is that to have introduction on electricity and magnetism. So I specifically identified this topic, induction, since while teaching physics courses for the past 6.5 years, this this topic is one of the most difficult that students find it very hard to understand. Maybe because unlike in the Newtonian mechanics, you have a free falling body, just an apple falling, or you just have an apple thrown upward, then it will stop momentarily, it goes back down. So you can really visualize. So on velocity, acceleration, rotational motion, you can visualize these things. But in terms of electricity and magnetism, um, if you really cannot visualize wholly, you cannot see the things that you're studying, it's quite hard to understand. So I specifically identified, yeah, induction for a topic in electricity and magnetism. So the first part I just want to share, since um, every start of my classes, in all of my classes for all of all the semesters that I've taught in the university. So I have this survey, and here I have several questions. I will share you most of the answers of my students. So still, I can attest that these are the most or the frequent answers of my students based on our first day like meet up or sharing about physics. So some of the common perceptions of students. So one of the questions I asked them, how do you find physics? Is it easy for you? Is it hard for you? Do you enjoy studying physics? Do you love physics? What can you say about your professor or teacher in physics in high school or from your other classes? So here are some of the answers of my students. So I can specifically identify these answers, even though uh, from the way back from the first year of my teaching. So first, that's right, physics is hard, and I will not like sugarcoat anything. That physics is really hard. That's a fact. So if it is hard, most of the students have this barrier coming into the class with a course entitled physics, or in physics 51 elements of physics. So oh, it's physics. So mahirap yan. uh, Hindi na kagad sila nag-effort to like to understand or appreciate first the course. So, meron na kagad notion na, naku, mahirap yan. Hindi ko na yan to kaya. So, second, most of their comments, hindi para sa akin yung physics eh. Parang it can only be understood by talented students, or specifically those students na nag-excel sa math. Or nung high school, sila yung mga top-notcher sa math. So, um, meron na kagad silang notion na hindi ako magaling sa math, I cannot do good in physics. So actually, when I was in high school, I'm not also good in math. Actually, before, I can say way back in high school that I kind of don't like to mild hate math. But since I love physics, I learned how to love math, something like that. So some of their answers, physics teachers are scary and boring. I don't know where kung saan ang gagaling yung mga sagot ng mga estudyante, pero most of when I asked them, why do you think that most of the physics teachers are scary or boring? They said sometimes most of their teachers are old, they speak so slow or so soft that they get bored. So oh, so they are really focusing on the teachers. That I can really attest na yung mga estudyante talagang tumitingin din naman sa guro. So kung mahirap yung subject, tapos yung guro mo yung may perception ka na si ma'am o si sir, medyo mabagal magsalita, mahina, hindi ko maintindihan. So parang tinatamad na ako. So may mga ganong perception yung mga bata. Fourth, all about formula and memorization. So they say, physics is just memorize all the formula and you can get through all the problems. But the thing is, I think personally, as a physics major when I was in college, I'm not good in memorizing formula, and I'm not that good, very good enough in mathematics. So what I usually recommend to my students, especially when we're discussing the first part, for instance, in Newtonian mechanics, I usually suggest that they could understand first the story or the physical system. So once they understand and describe the physical system, they know the story, what's happening. After that, you can incorporate the math to describe the phenomena, or describe the story of that you're observing. So essentially, if you understand what's happening, you can somehow incorporate the math. I-divide ba to? So subtract, i-multiply. Dapat ba negative? Decreasing ba siya? Increasing? So later, hopefully, in terms of the specified topic that I chose, hopefully I can somehow demonstrate that if you cannot, if you get intimidated by all the formula and all the math part, but first learn to understand the story, what's happening. So you can see the beauty of physics beyond the math when you first understand like the basics or the foundations of it, where the story is coming from. So yeah, they said physics is for introvert, just solving problems, but physics really tells a lot of stories. Next, we don't need it in our course or in our degree program and in our work. So most my question to this answer is that why are you taking this course? For instance, Physics 51 or other physics courses. Is it just a requirement to your course? Is it because you like physics, or is it you hate physics? So the least answer that I gathered is that the least is that they don't like physics or they hate physics. I don't know kung takot lang sila na baka, bababaan ko to ng grade kasi I hate mo pala yung physics. No, I think it's better answer than it's just a requirement to my course. And of course, if you love physics, no argue, no argument between us, since of course you love it. So you will try to understand even though it's hard. So, but if you answer we don't need it, I think we don't need it. It's just a part of our degree program. I think you're missing the point that physics is really a fun subject that could be used fundamentally to appreciate better our specialized courses. For instance, in engineering or in biology or in chemistry, even in social sciences. So sometimes it since we have this notion that it's hard, it's not for me, physics is not for me, it's just for talented students in math that are good in math. Di ko na to aaralin, di ko na mag-effort para intindihin. But let's have the realization that in every story, there's physics and we can translate it in math at hindi lang siya basta requirement para sa degree program natin. So I think by that, let's crash the barrier that it's hard, hindi ko na to kakayanin. Lalo na ngayon, di ba? Parang virtual classes, puro modules tayo, hindi natin masyadong nakikita yung teachers natin, or the consultations are more limited since hindi tayo makapunta physically sa professor natin, hindi tayo makapagtanong. So sa atin, we just have to have another perspective. And the last is, yeah, it's just a requirement in my study plan. So same answer. These are the top answers that most consistently, almost every semester, most of my students answer this. Next, on the teacher's thoughts, ito naman yung pumasok sa isip ko after teaching for few years, I think 6.5, yeah, six and a half years, and being a student, because as a BS Applied Physics when I was an undergrad and while teaching, I'm doing my master's, so I can see the perspective of a teacher and a student. So one thing that I realized is that there is really a difference in the learning style of the student and the teaching style of the teacher. So parang huwag mong sisihin yung sarili mo na hindi ko maintindihan si ma'am o si sir, parang hindi ko talaga to kaya intindihin. But the thing is maybe the learning style, your learning style, and the teaching style of your teacher, hindi lang sila tugma. So that's okay. So you just have to adjust, or you can just have to consult to somehow answer your questions in a way that you can understand more. You can understand the concept more, for instance. So so sa akin naman, for instance, my teaching style is more on how I understand the certain topic. I will write that and I will make a presentation or PowerPoint about it. So kung hindi ganon yung pagkakaintindi ng mga estudyante, so it's my job to translate it to them. At kung hindi pa rin, kasi iba-iba yung learning style and teaching style ko. So again, we just have to meet halfway. So later I can give some tips on how most of my students, since Physics 51 is one of the new courses that we offer, so ito yung medyo marami kaming struggles when we first offered the course. So teaching to convey, not to intimidate. What do I mean by that? So I think based on my personal experience, there are professors and there are students that get intimidated with their teachers. Like, naku, nakakaya magtanong kasi para sabihin ni sir or ni ma'am, ba't di mo alam yan? Parang basic concept siya. So again, asking question or clarification, it's not for the teacher, it's always for you. So if you genuinely do not understand a certain topic, you just have to ask it. And for us, for teachers, so we just have to convey it in a way that it can be transmitted to students. I think personally, again, based on my experiences, ako din medyo na-intimidate din ako minsan sa mga teachers ko before, for instance. So parang nahiya ako magtanong. But again, let's break the barrier, lalo na ngayon since mas kailangan nating mas magtanong. Next difference in the student's academic background. So I understand when I first taught Physics 51, most of the students are engineering students, math, I think, or applied math, physics student, biology students, but their stream or their senior high school strand is not STEM, for instance. Meron akong mga naging estudyante, ano sila, is it ABM, the business? Meron ako from sports. So sabi nila, on our first meeting, we just have a recall of vector and differential equations. So, yung iba, I had an experience, umiyak siya after the lecture, sabi niya, sir, wala akong background about that. So, paano yun? So, susuko ka na lang? Or parang, ayoko, shift na ba ako? I-drop ko na ba yung course? Parang, for me, it's, kung magkakaiba tayo ng starting point, but we have to persevere if we really, our focus is to understand physics, for instance, or to appreciate physics. So, pwede tayong manood ng mga videos sa YouTube. So marami dyang mga crash courses that could help us understand the fundamentals. So extra effort lang siya. Again, lahat ng estudyante hindi pantay-pantay yung starting point. Kasi I also feel that na yung ibang estudyante parang intimidate or nahihiya din sa ibang nilang kaklase na sobrang galing sa math kasi panglaban pala siya nung high school sa math. So ang galing-galing niya, naintindihan niya na kagad yung solutions. But kung nari iba yung strand kung saan ka galing, kung ma-intimidate lang tayo, malulungkot lang tayo, or ma-depress lang tayo na hindi natin maintindihan, so we can work on it. So umpisa, medyo mahirap talaga, but we can work on that. Maybe you can ask your professors or teachers for supplementary readings, some extra exercises, some additional books that you could read that they use as the reference para mas lumalim yung pagkaintindi natin. So again, physics is really, I will not sugarcoat it. It's not easy. It's really hard. So kung mahirap na siya, ano pa yung magiging respond natin? Susuko ba tayo? So of course not. We're here to excel. So we just have to work hard. So next, importance of self-paced learning. I just realized this when I'm studying in masters. Lalo na siguro ngayon, sobrang naging na-highlight siya or naging mas applicable siya since remote learning na tayo. So, hindi lahat ng classes asynchronous. So, minsan magbibigay ng modules or minsan magbibigay ng exercises or ng problem sets and you have to study at those materials on your own. So, huwag tayo ma-intimidate. Again, kung mahirap siya, syempre, physics is really hard. But, sabi nga ni Marie Curie, there's nothing to be feared. But for us to fear less, we just have to study more. We have to understand more. So ganun, extra effort tayo. So yung self-paced learning, ako noon habang nag-aaral, habang nagtatrabaho, sobrang stressful na yung pag-aaral ng physics. So parang, I have to know anong time ako dapat nag-aaral, saan ako mag-aaral, paano ako makakapag-concentrate, ano yung style of learning ko, na hindi ako dependent sa teacher. Kasi kung hindi ko naman kaya mabago yung teaching style ng teacher ko, kasi kung matagal na siyang ganun yung way ng pagturo niya. So I have to adjust. So we have to understand our learning like mode, kung paano tayo natututo, and we have to self-pace ourselves. So ako ba ay effective and efficient ba ako mag-aral ng 24/7 or 3 hours a day, focused lang? So iba-iba tayo, but you have to know. So especially remote learning, you have to know and understand kung paano tayo natututo on our own, not dependent on the teacher, not dependent on the materials. Ako, ito lang yung binigay sa akin, ito lang yung babasahin ko. I think physics doesn't work that way, na kung ano lang yung binigay sa inyo, yun lang yung babasahin. Kung ano lang yung slides, yun lang yung aaralin. Ano lang yung suggested videos, yun lang yung papanoorin. Really, to understand and be confident in doing physics, just really have to read and expand and have many resources. one of uh, the key learnings, again, from my personal experience and from my, as I've seen from my previous students, we have to encourage intrinsic motivation. Since in physics, parang kahit sabihin ko, okay, may problem set, may deadline, may exam, may quiz. So parang nape-pressure tayo mag-aral just to pass an exam. But I think since physics is hard, it will not work another hard it will not work another hard thing to add on ourselves para matutunan yung isang mahirap na bagay. Do you get me? Parang we have to understand first, that's why I like the title. We have to first remove all the barriers that hinders for us to face physics. Then we can start appreciating it, understand how it is related to our daily lives, into our field of study, kung kayo ay biologist or kayo ay chemist, engineering students. So we really will have to contextualize kung nasaan ang physics doon sa field ko. And when we find that, so makikita natin that, oh, ma-appreciate ko na to. Dito pala siya nagagamit. O sa economics, may econophysics pala. O sa medicine, may medical physics pala. O sa biology, may biophysics. Sa chemistry, may chemical physics. So nakita natin yung importance ng physics to our respective field. So I think doon nagsa-start yung intrinsic motivation that we're studying to learn, not just to pass or ace the exam, or not just to integrate and find the solution or have the derivative. So yeah. And lastly, mostly for the teachers, I think be relatable. So when we're doing our lecture slides before, so yung examples, kailangan medyo relatable. Even my jokes or my, not jokes, but my actual illustrations during lecture class, kailangan medyo relatable. Kasi iba na yung generation. So yeah, so that's all. So if you have other comments or questions regarding physics, again, I'm not an education major, but I think from my experience, maybe I can help you to somehow give some tips on how to effectively somehow to convey physics lecture, for instance, to our new students, new generation of students. Yeah. So let's proceed to the first topic. So I'm having first thermodynamics. So first, as a definition, it's the study of energy transformation involving heat, mechanical work, and other aspect of energy, and how this transformation relate to the properties of matter. So ako personally, kahit nag-aaral ako ngayon, hindi ako makasaulo ng or makaintindihan ng long definitions. I usually have a concept map or like an outline kung ano yung mapapag-aralan ko ng buo. So kaya yung presentation ko, since that's how I understand and how I prepare to learn for a certain topic, that's how I will teach. So parang ganun yung parang teaching style ko. So yeah, so we have here thermodynamics. It deals with energy transformations. So we have a lot of different types of energies involving, we have heat, work, and temperature, and it is related to the properties of matter. So ngayon, nakita ko na yung buong definition and a concept map, for instance. So later, yung details, ano ba yung heat, ano ba yung work, ano yung temperature, how is it, how they are related with each other, at paano nakaka-apekto yung energy transformation to the properties of matter. So the details, so parang from a bird's eye view to the tiny details of the concepts. So that's how I understand it effectively and efficiently. So kung yung estudyante natin or kayong mga estudyante, hindi kayo ganon, parang mas gusto nyo details muna, then you will build your way up, kung yung teacher nyo ganon, so alangan namang sabihin natin na, sir, ma'am, ayoko ng ganyang PowerPoint or lecture, ano na lang po, baguhin nyo po para sa akin. So parang, of course, we can do that, but of course, since sobrang dami ng estudyante, for us as students, we can somehow have a lecture on our own. So kung paano natin naintindihan, then we can counter-check to the lecture of our professors. So with that, we have the concepts, we have temperature, we will discuss temperature scales, and we will define the thermal equilibrium or the zeroth law of thermodynamics, and how temperature is different from heat. So how is it related to work in energy? Its effects, such as change in temperature, change in phase and expansion, ways of transferring heat. So we have conduction, convection, radiation. And finally, we can generalize the laws of thermodynamics. So we have the zeroth law, thermal equilibrium, first law, energy conservation, second law, entropy. So dito, kapag nakita natin yung parang the whole picture of the thermodynamics on a certain topic, for instance, so makita natin, ganun pa sila related. So hopefully this could help. Ako, ginagawa ko siya until now if I'm reading an article or reading a certain chapter of a book. So gusto ko makikita ko siya naka-concept map na may mga arrows so that I can somehow visualize. Medyo visual person ako. So gusto ko ma-visualize kung paano sila related. And essentially heat engine and refrigerator. So now, temperature, as from, I think from grade school days, it's defined as the measure of how hot or cold the body is. So measured by a thermometer or by just touching. And it determines the direction of heat flow, or a more technical term, it measures the random average translational kinetic energy of molecules, of the body. So from our previous lectures, alam natin, kinetic energy, it involves kinetic energy, 1/2 mv squared, so may velocity, nagmo-move. So yung sabihin pala, kapag mas mabilis, nagmo-move yung object, ito ba ay mas mainit, ito ba ay mas malamig? So somehow we can relate those terms. So it's just in terms of equation, it's 3/2 kT, where Ke is the average kinetic energy of the molecules, K is some Boltzmann constant, and T is the temperature. So we can see here that as we increase the temperature, the average kinetic energy will also increase. So kung mas mataas ang temperature, kung nagpapakulo kayo ng tubig, makita natin, mas bumibilis yung molecules ng tubig. Tama ba? So from that, kahit kunyari hindi natin alam yung equation, but you can somehow relate to a physical phenomena. So we have three temperature scales. We have the Celsius, we have the Fahrenheit, and we have the Kelvin. How are they different? These are the relationship between the scales. But how are they different? So makita natin, for instance, Kelvin is just calibrated at the absolute zero. And yung absolute zero from the previous slides, it's the scale whose 0 point is at which all molecular motion stops at negative 273.15 degrees Celsius. So we have here degrees Celsius calibrated when it is 0 when the water freezes. So somehow, just different scales of temperature. So now we define thermal equilibrium, or the zeroth law of thermodynamics. So for instance, if we have a system enclosed in this red box, and we have object A, B, and C. So if body A is in thermal equilibrium with body B, they're at the same temperature, and B is in thermal equilibrium with C, then A is in thermal equilibrium with C. So what if we have two bodies? We have body A, we have body B. For instance, if TA, or the temperature of body A, is greater than the initial temperature of body B, what will happen is that at some time, they will reach thermal equilibrium. So this is the same concept. Saan natin ito makikita? So kunwari, we have a thermometer. Ay, sayang, may thermometer. Anyway, so I have, for instance, we have a thermometer. So yung luma, kasi ngayon may digital na, diba? So parang yung luma, yung merong LED sa gitna. So kapag kukuha tayo ng temperature natin sa katawan, ano yung unang ginagawa? Wala pala akong kausap. Sorry. So ano yung unang ginagawa? So parang ginagana natin, no? So parang hindi kagad natin nilalagay sa kilikili natin, for instance. So after that, ilalagay sa kilikili. Parang tinitingnan ba kagad natin? Hindi, di ba? So initially, if we have a hotter body, if we have a higher temperature body, kunwari may lagnat ako, wag naman po sana. So kunwari may lagnat ako, and then we have a lower temperature body, we have a body A, C thermometer, nilagay natin siya. So makita natin dito, kunwari si TA yung katawan ko, TB si thermometer. Kapag makikita natin siya, hindi pa sila at the same temperature. So at some time, di ba, mag-aantay pa tayo ng ilang minuto, hindi naman kagad natin titingnan, because we are waiting for the thermometer and my body to reach at least a thermal equilibrium. So kapag tinignan natin yung temperature sa thermometer, actually it is reading its own temperature, which is in thermal equilibrium equilibrium with our body. So ganun siya. So now, na-define natin sa temperature. It can be Kelvin, degrees Celsius, or Fahrenheit. So heat, on the other hand, it is an energy. So from your Newtonian mechanics, for instance, or from your previous lectures, energy, ano ang symbol niya? It can be Q, for instance, for heat. It's scalar, and its unit is joule. So isa rin sa mga technique ko na rin ako, since hindi ako marunong or hindi ako makasaulo ng formula ng maraming bagay, or even the definition of a certain physical quantity, if you know the unit, sometimes makikita na, marirelate na natin sa kung anong ibig sabihin niya. So di ba, tinuturo yan at first lecture for in-dimensional analysis. So makita natin ano yung unit ng isang physical system, ano yung other, paano siya katulad or kaiba sa other physical system by looking at the units. So makikita mo na yung difference nila. So again, heat, it's an energy, so it's in joule, transferred from one system in another system because of the difference in temperature. So kay thermometer pala, at saka dun sa katawan ko, so there is a transfer of energy, and that transfer of energy is what we call heat. That energy transferred from one body to another body. So later makita natin, paano kaya nagte-transfer itong heat na ito? From a lower temperature body to higher or higher to lower. Of course, it's kind of easy, but again, the concept is you just have to understand the physical system first. Okay? So some units of heat, it could be calorie or British thermal unit, some just relationships. Kung ano lang yung, pwede natin lang silang baguhin lang yung units. So just like the temperature in terms of Kelvin, degrees Celsius, Fahrenheit. Yeah. So now, looking at this Joule's experiment for determining the mechanical equivalent of heat. So kunwari meron tayong falling block, itong kulay, ano ba to? Red. Yeah. We have a falling block, a block that rotates the paddle. So meron tayong paddle dito. Kapag nahulog to, iikot to, iikot. Kita nyo po ba yung cursor? Yeah, iikot din tong paddle. So habang umiikot yung paddle na nasa tubig, it can cause the temperature of the water to increase. So now, with this Joule's experiment, we can have the interaction that causes a temperature change in the water. It's fundamentally a transfer of energy from one substance to another. And this energy transfer taking place solely because of temperature difference is called heat flow or heat transfer. So dito, later may clue na kayo, okay, meron tayong weight dito, tapos umiikot siya, there's mechanical energy. Habang umiikot, meron siyang change in temperature. So mas makikita pa natin yung relationship ng mga physical quantities na yan later on. So some notes. As we all know, the direction of the spontaneous energy transfer is always from a warmer object to a cooler object. So para lang yan in potential energy from high potential to low potential. So from warmer or higher temperature object to a lower temperature object. So that is the spontaneous, or that's the natural direction of how heat flows. So again, matter does not contain heat. Matter contains molecular kinetic energy and possibly some potential energy. But again, heat, it is the energy, the amount of energy transferred from one object to another object with difference in temperature. And heat is, again, as I mentioned, energy in transit. So now, what are the effects of heat transfer? So we will discuss first, we have temperature change as demonstrated a while ago. So kung ang heat ay pumasok from object 1 to object 2, pumasok sa heat, ano nga yung consequence? There is a temperature change. And alam natin, mas mataas kanina from our previous definition and equation, kapag mayroong pumasok na heat, it can cause greater motion of the kinetic, it can cause an increase in kinetic energy of the molecules of that object. And thus we're expecting a temperature change. Next, we have phase change or phase transition. So I just put an asterisk here, phase transition versus phase transformation. I just read this from one of the references that I use. So it is technically more appropriate to use the term phase transition because phase transformation implies that there's a structural change in the matter itself. So we are more on a phase transition, just different in phase. So kumbaga, tubig na yellow, yellow naging liquid water. So tubig pa rin, H2O pa rin. So meron lang physical structure, meron lang tayong changes in terms of it's their interaction. And third, we have thermal expansion. So now first, let's discuss temperature change. Calorimetry is just a process of measuring heat, and we define specific heat capacity, small letter C, with the units. Sige nga, try natin yung dimensional analysis, joule per kilogram Kelvin. So we have unit of energy per kilogram or gram and multiplied by temperature. So ano kaya ibig sabihin ng specific heat capacity? Kahit hindi pa natin alam, it is somehow an amount of heat, tama ba? Joule or in calories for a kilogram or for a gram of that substance to increase its temperature by a Kelvin or a degree Celsius. Tama ba? Yeah, the quantity of heat or the amount of heat Q required to increase the temperature of a material of mass M from T1 to T2. So again, kung nakalimutan yung definition o ano yung physical meaning ng isang quantity, so from its units, pwede nating somehow ma-deduce ko ano yung ibig sabihin niya. And to measure the heat absorbed or released when there's a change in temperature, we can compute the heat Q is equal to M, the mass of the object, times the specific heat capacity of the object times its change in temperature. So now I have listed here different substances with their specific heat. So let's consider germanium and iron. So we can see here that germanium has a lower specific heat than iron. Tama? So from here, sino kaya dito yung mas madaling initin? Mas konti lang yung kailangang energy para itaas yung kanyang temperature from T1 to T2 for a kilogram, for instance, of germanium or iron. So we can see here that since the higher the specific heat, meaning the higher the energy it requires for a gram of iron to increase its temperature by from T1 to T2, for instance. Okay? So now, conservation of energy, so hindi na rin to bago sa atin. So from Newtonian mechanics, conservation of energy states that energy can be created nor destroyed. It can only be transformed from one form to another. So since heat is an energy, it is conserved. So it allows us to write then this equation that the heat gained by an object, so kanina, alam natin, mas mataas yung temperature ng katawan ko compared to kay thermometer. So ano yung direction ng heat? From high temperature to low temperature. So from my body, with my hot body, with my higher temperature body towards to the lower temperature thermometer. Tama? That's a direction. So yung Q gain, sino yung nag-gain ng heat? C, thermometer. Tama? Sino yung nag-loss ng heat? Yung katawan na mas made yung temperature. So the heat gained by the thermometer, the heat lost by my body, for instance, if energy is conserved, their sum is 0. So yun lang yan. So for instance, let's have temperature change. So an example, so a 0.01 kilogram piece of unknown metal heated at 100 degrees centigrade and dropped into a bucket containing a 0.5 kilogram of water at 20 degrees Celsius. That's the question. Determine the specific heat of metal if the final temperature of the system is 50 degrees Celsius. So ganun din, different problem. So ang naintindihan natin, thermometer at saka yung body with higher temperature. So ngayon meron kang unknown metal, 100 degrees Celsius, meron kang water, 20 degrees Celsius. Pinagsama mo sila after reaching thermal equilibrium, reaching a final temperature of 50 degrees Celsius. So makita natin sino nag-gain ng heat at nag-loss ng heat. So everything is given and we can now find the specific heat of the metal. So again, given. So again, yeah, parang yung turo ng grade school. List all the given, write what is asked. So everything is given, specific heat of water is also given, and we're asked to find the specific heat of the metal. So we can write an equation and we have one unknown. Therefore, we can solve the missing the missing physical quantity. So from the conservation of energy, the heat lost by metal is the same as the heat acquired by the water. Again, given they are isolated, there's no heat or energy loss in our environment. So the heat of the water is equivalent to the negative heat of the metal, or the sum of the heat absorbed by the water and the heat released by the metal must be equivalent to zero. Paano ko nalaman kung sino nag-absorb at nag-release? So nakita natin kung sino yung bumaba yung temperature, since alam natin that a system with a decreased temperature released heat, tama ba? From sa kanina nating definition. So now, we can solve this equation. So just have MC delta T, M ng metal, C ng metal, change in temperature, and the MC delta T of the amount of heat absorbed by the water. So here, just plug in everything, and we are to ask the specific heat capacity of metal, and we can compute this. So given this specific heat capacity of an unknown metal, since specific heat capacity is an intrinsic property of the material, of an object, for instance, para, kunwari, ang water, specific heat of water is 4,186 joule per kilogram degree Celsius. So kung meron kang isang timba ng tubig, isang pool ng tubig, at isang baso ng tubig, given they are the same water, kung seawater sila, potable water, or the same water, they have the same specific heat capacity. It's an intrinsic property of a material. So therefore, we can also, since we computed the specific heat capacity of an unknown metal, we can identify what metal it is. And from this, iron has a specific heat capacity of this value. So kung kunwari, biologist kayo, or in terms of buyers, engineering, you want to know the specific heat capacity of a certain material you're dealing with, but you do not know kasi binili na lang somewhere or napulot na lang siya. You want to determine anong klaseng material siya. So you can do calorimetry so that we can compute for the specific heat capacity of that object, an unknown material. You can compare it to the known specific heat capacities of different materials. Then you can identify it. Third, we have phase change or phase transition. So phase is a description of a specific state of matter, either solid, liquid, gas, wherein the properties of matter in state is essentially uniform. So phase transition, solid to liquid, melting, solid to gas, sublimation, liquid to gas, vaporization. So these are the common phase transitions that we've studied, I think, starting from grade school. Yeah. So during phase transition, it requires heat, of course, since there's a change in phase. For instance, melting from solid ice to liquid water. And the heat is either supplied, it's positive, or removed from the system, it is negative. So kapag lumabas sa system, negative yung Q, yung heat. Pumasok sa system, it's positive. And the removal of the supply of heat does not change the temperature of the matter during phase transition. Question, bakit kaya? So kunwari, sino po sa inyo yung nagluluto sa bahay? Diba kunwari, kapag kumukulo na, papansit canton, yun na lang para mas mabilis. Usually na, kaya kong lutuin. So kung nagpapansit canton na, kapag kumukulo na, anong sasabihin ng guardian natin o ng nanay natin? O patayin mo na yung kalan, patayin mo na yung apoy kasi kumukulo na. Bakit naman kailangan patayin yung apoy kapag kumukulo na? Aksaya lang yan sa gasol. O kung naka-induction kayo, aksaya yan sa kuryente. Bakit aksaya? Kasi hindi na natin kayang itaas yung temperature ng kumukulong tubig. Hanggang 100 degrees Celsius lang siya. Tama ba? Yun ang boiling point of water. So yung further supply of energy or of heat to the boiling water will not increase the temperature. So ano saan nagagaling yung heats? Parang, Kuya Dustin, nakala ko po ba conserve yung heat, yung energy? So bakit nag-supply ka ng heat sa kumukulong tubig, hindi tumataas yung temperature? So saan napunta yung heat? Okay, so yun yung the concept behind during phase transition is that the energy supplied during phase transition, for instance, during boiling, is used to change the phase of our object. So kung tubig, liquid water, kapag nag-supply ka ng heat dyan, maghihiwa-hiwalay sila, syempre may energy yan eh. May energy, may attraction silang dalawa. So kapag nag-supply ka ng heat, and when the energy is enough, it can break the bond. So from liquid, naging gaseous or vapor na sila. So ganun din, if we have ice, so rigid structure, crystallized structure, for instance, and if we supply heat, so hindi na natin matataas yung temperature ng ice, but we can melt the ice from solid ice to liquid water. So bakit walang increase or change in temperature? Because the further addition of energy or heat is used for changing the phase of the object. Yeah, and during this phase transition, the heat required for phase transition is given by this ml. So hindi siya laro or hindi siya milliliters. Anyway, ml. It's positive again when heat is absorbed, and it's negative when the heat is released. So nakita natin walang delta T kasi there's no change in temperature. As again, solid to liquid in melting, liquid to solid in freezing, we have negative. Bakit ay negative? Nagre-remove tayo ng heat. Okay? So where MLF, where F is L sub F is the latent heat of fusion. So constant again, just like the specific heat capacity. Liquid to gas, we have vaporization. We have positive since we are putting, or we have heat, and gas to liquid, we have condensation. So ano kaya ang unit ng, sige nga, yung latent heat, ano kaya yung unit niya? Sige nga, from dimensional analysis, hindi ko naman nasabi. Yeah, hindi ko pa naman nasabi. Heat is energy, joule. M can be kilogram. So ano yung L? So for the left-hand side to be joule, so dapat ito ay joule. The latent heat should be joule per mass, kilogram or grams. Yeah. So again, another example, solid to gas, sublimation, and gas to liquid, we have deposition. So here we have a dry ice, which is a solid carbon dioxide at negative 109 degrees Fahrenheit. So it's really cold and must be handled with care or end up like a freeze burns. And it's called dry ice because it sublimates and goes directly from solid to gas state without ever getting wet. Now, this is a boiling transition curve, boiling curve of water. So where we identify the melting point of water and the boiling point of water. So here we have from negative 25 to 0, we have warming of ice. And from B, so from this part, from B to C, we have melting of ice at 0 degrees Celsius. Again, there is no change in temperature during change in phase. And C to D, we have liquid water, warming of liquid water. D to E, we have liquid water vaporizes at steam, and steam warms from E onwards, or 100 degrees Celsius onwards. So here, when the ice is warming, when the liquid water is warming, and as the steam warms, the temperature of water changes. And during this period, when we have change in temperature, there is heat added, which is equivalent to Q is equal to MC delta T. So usually, yung mga estudyante, kapag sinabing find the heat absorbed by a negative 25 degrees initially, at negative 25 degrees Celsius ice to 125 degrees Celsius vapor, oh, may change in temperature, MC delta T lang yan. Ano yung delta T? Negative 25 to 100. Ano yung C? C of water. Yung mass, kung di nagbago, then mass. But no, since we have different phenomena getting involved in the process from negative 25 to 0, 0 to 100, and 100 to 125, for instance, there are changes in temperature. So you have 3 different changes in temperature at different phases. And during melting of ice and vaporization of liquid water, so during this periods, temperature stays constant and phase changes proceeds as heat is added. Paano ma-compute? ML. M times the latent heat of kung ano mang change in phase that we are considering. So the key concepts, the first law, the concept of energy in the first law does not, however, account for the observation that natural processes have a preferred direction of progress. And the first law is symmetrical with respect to the initial and final states of an evolving system. So see, di ba ang hirap kapag ang haba ng definition. So later, mas maintindihan natin siya. And second law, we have asserted that a natural process runs only in a sense and is irreversible. So dito na papasok yung ating third or the second law, the third law of thermodynamics, or the second law of thermodynamics, essentially the third. So for example, again, as I mentioned, heat always flows spontaneously from hotter to colder bodies and never the reverse, again, naturally or spontaneously, unless we will realize that unless there's an external work performed on the system. So the second law will describe those phenomena. Okay, so if there's no other question, yeah, let's proceed to the second law of thermodynamics. So again, it deals with the preferred direction of the thermodynamic process. So yung previous two laws, hindi pa natin define, but the second law will define ano yung preferred, ano yung gusto niyang mangyari, essentially. Saan siya gustong pumunta. Okay? So we have five equivalent statements of the second law of thermodynamics. We have the Kelvin, the Clausius, the heat engine, refrigerator, and the entropy statements. These are all equivalent. It just depends upon the application. So as you can see here, even in different applications of physical quantities or concepts, it really depends on the application. So if we understand the application, we understand the story, we understand the physical system, what's happening, we can somehow really like write, not in toto, but we can really write somehow the idea of the different laws or concepts of physics in general. So the Kelvin statement, it's impossible to remove thermal energy from a system at a single temperature and convert it to mechanical energy without changing the system or surroundings in some other way. Ang haba, diba? So later we can just visualize. I just show you an example, and you can just write your own statement and on your own words, the Kelvin statement. And Clausius statement states that heat cannot by itself pass from a colder to a warmer body. So kasi sabi natin kanina, di ba, from higher temperature or from warmer body going to a lower temperature body. That's the spontaneous direction. So now let's consider a heat engine. So heat engine is just a device that converts internal energy into a more useful form, such as mechanical energy and electrical energy. So here we have a heat reservoir with TH with higher temperature. We have a cold reservoir, essentially a system with a lower temperature system. And we have here a work done by our engine. Okay, so essentially the heat input or Q in is equivalent to the change of the internal energy plus the work done by the system plus the heat released by our heat engine. So here are the three characteristics of our heat engine. Heat is absorbed from the hot reservoir. So here's the hot reservoir. Mechanical work is done, and heat is given off to a cold reservoir. Yeah, from hot reservoir, heat is absorbed. I will do some mechanical work, and I will expel some of the heat. So okay, that's just the definition of heat engine. So again, heat engine, we have input heat. Kung meron tayong input heat, ano yung one of the consequences of heat? Change in temperature. And then we can have another physical quantity. We have output of work. So here is an example of heat engine where the working substance is water. So at high temperature, the gaseous water or the steam pushes the piston here, which causes the wheel to turn. And this is really just a simple illustration of the mechanism of the steam-powered trains. So we have application of heat, we have a change in phase, change in temperature, and with that, it make a piston to do work. So parang same illustration. So mas simple lang itong kanina natin. So now the energy flow diagram and its efficiency. So again, note that in ideal reservoir, it gives off and or absorb heat without changing its initial temperature. So ibig sabihin, si hot reservoir kahit nag-release siya ng heat, tama ba? Nagpunta kay heat engine, hindi magbabago yung temperature niya. Ganun din kay cold reservoir, kahit nakatanggap siya ng heat output by the heat engine, same pa rin yung temperature niya. Okay? The net heat absorbed per cycle is equivalent to the sum of the heat from the hot reservoir plus the heat absorbed or released by the engine from to the cold reservoir. Or in terms of its absolute value, since QH or the heat from the reservoir, it's positive because it's absorbed by the engine, and the QC or the heat released by the engine or absorbed by the cold reservoir, it's negative since it is released by the engine. Okay, so the work done by the engine is defined by the change or the difference between the absolute value of the heat absorbed by the engine from the hot reservoir minus the absolute value of the heat released by the engine or released absorbed by in the cold reservoir. So now thermal efficacy E is just equivalent to the work done. So again, nakita natin kung meron tayong work done over the input heat for coming from the hot reservoir, or is equivalent to 1 plus QC over QH, or in terms of its absolute value, 1 minus the absolute value of the ratio of the heat released by the engine over the heat absorbed from the hot reservoir. So again, E is equivalent to 1. We have 100% efficiency. It can only be achieved when QC is 0. So from this equation, when QC is 0, 0 over some value of QH will be 0. Ang E natin or the efficiency is 1. Okay, so there is no energy expelled to the cold reservoir. So ano lang yung nangyari from our previous equation? So lahat ng nakuhang energy from the hot reservoir, na-convert lahat into work kasi wala nang lumabas sa cold reservoir. Tama? So if we have 100% efficiency, sabihin, sobrang efficient kasi nagawa ng trabaho, maraming trabaho nagawa. Walang nasayang na lumabas lang sa cold reservoir sa environment. Okay? So it is impossible, but it is impossible to construct a heat engine that operating in a cycle that produces no other effect than the absorption of energy from a reservoir and the performance of an equal amount of work. Okay? So QC cannot be equal to 0, and some QC must be expelled to the environment, as I mentioned, and E cannot be equal to 100% efficiency. So laging merong ni-expel na heat. May kinuha ka na heat, may gumawa kang trabaho, hindi lahat ng heat na nakuha mo nag-produce ng same amount ng trabaho. Yung iba, na-expel. Okay? So now the heat engine statement, it is impossible to extract amount of heat QH from a hot reservoir and use it all to do work. So some amount of this heat must be exhausted to a cold reservoir. So that's the heat engine statement. So now the refrigerator or heat pumps, these are heat engine operating in reverse. Okay? So ngayon, nabaliktad lang yung arrow. So kukuha tayo ng heat from the cold reservoir. I will have an input work. Maglalabas tayo ng heat to the hot reservoir. So it's like reversing the spontaneity of the direction of the heat flow from high temperature to low temperature. Tama? So ngayon, from low temperature to high temperature, possible pala siya. Pero ano yung meron from our illustration? We must have an input work. So from the first law of the cyclic process, the sum of all the heat coming from the hot reservoir, coming from the cold reservoir, and the work must be equivalent to 0. And because QH and W are negative, because QH and W are negative in this case, getting its absolute value, it's equivalent to the heat released in the hot reservoir is equivalent to the sum of the heat absorbed from the cold reservoir, or absorbed from the object with lower temperature plus the work done on the engine. Okay. So a refrigerator does the opposite, as I mentioned, and it takes heat from a cold place and it gives off to a warmer place. So usually in the room temperature where refrigerator is located. So tama ba? Kung meron tayong ref, pinapalamig natin yung loob. So we have a lower temperature sa loob, gagamit tayo ng work, sasaksak natin sa kuryente, it will pump up heat from the inside of the refrigerator palabas para lumamig yung loob. Nakakita ba kayo ng ref na malamig yung loob pero hindi nakasaksak? There's no work done. So of course, the natural way is to reach thermal equilibrium. Tama ba? Now, so a heat engine has a net output of a mechanical work. On the other hand, the refrigerator requires a net input of mechanical work for us to reverse the process to get heat from a lower temperature body to the higher temperature body. Okay? So now some coefficient of performance of the refrigerator para may idea kayo kapag bibili kayo ng ref later on. So it's K, it's just the ratio of the absolute value of the heat absorbed from the lower temperature body or from the cold reservoir over the work input. Or in terms of the heat, QC over QH minus QC. So from an economic point of view, ano yung best na refrigerator na bibilhin nyo? When the best refrigeration cycle is the one that removes the greatest amount of heat, QC, from the inside of the refrigerator for the least expenditure of mechanical work. Tama ba? So from the equation, so meron tayong QC over W. So here, the larger the ratio, the larger the value of K, the better the refrigerator. So kung mas mataas, kung yung ref nyo, kapag bibili kayo, ano yung value kuya ng coefficient of performance itong ref na binibenta mo? Sige nga, compare ko sa ibang brand. Ano yung value ng coefficient of performance? Ano ba siya? Baka kasi baka mataas nga yung coefficient of performance kasi ano kaya yung possible reason? Pwedeng first, we remove, yeah, that's right, we remove a large amount of heat inside. So kapag mas kaya niyang mag-alis ng maraming amount ng heat from the inside of the refrigerator palabas, mas better yung performance ng refrigerator. Or baka pwede rin namang list yung kuryente na kailangan or list yung mechanical work na kailangan gawin ng ref para palabasin or mag-extract ng heat from the inside of the ref palabas. So kasi baka mamaya, same performance. Pero tingnan nyo, yung isa, sobrang kailangan pala ng, sobrang baba pala ng, na heat, ng bagal pala niya magpalamig. So masyadong mababo yung QC niya. Or sometimes, masyadong, yung isa, baka yung iba, yung titingnan is yung W, yung denominator. Baka makita nyo, ito mas pagod kasi mas kailangan niya ng more work. So hindi efficient yung performance ng ref natin. So you just have to balance the ratio of this coefficient of QC and the work done. So again, heat flows spontaneously from hotter to colder bodies, never the reverse, but a refrigerator does take heat from a colder to hotter body, but its operation requires an input of mechanical energy or work. Okay, so hindi siya natural. Okay, so generalizing this observation, we state that it is impossible for a refrigerator working in a cycle to produce no other effect than the transfer of thermal energy from cold object to hotter object. Okay, now we introduce another term, entropy. Again, still same equivalent definition, different application, where entropy is defined as another just state variable related to the second law. And the change of entropy between two equilibrium states is given by the energy QR transferred along the reversible path divided by the absolute value T of the system interval. And haba, but essentially it's just this. So when the energy is absorbed, Q is positive, and entropy from this equation, mas mataas ang entropy natin. So when energy is expelled, Q is negative, tama, palabas eh. And entropy, makita natin, decreases. So now, let's consider, for instance, the first photo, melting of ice. Ano yung masasabi natin sa entropy? So, nag-release ba siya or nag-absorb ang heat? So, nag-melt eh. So, nag-absorb siya. Tama ba? From ice, naging liquid water. So, nag-absorb siya. So, kung nag-absorb ng heat, entropy increases. And dun sa isa, tumigas yung tubig dun sa palibot ng apple, nag-expel ng heat. Kasi from liquid water, naging ice. So, Q is negative, entropy decreases. So, entropy can also be described in terms of disorder. I think it is the most popular definition. A disorderly arrangement is much more probable than an orderly one if the law of nature allowed to act without interference. So for instance, pagkagising nyo ng umaga, pupunta kayo sa school. Shucks, hindi na pala pupunta sa school, no? O magvi-video conferencing kayo, magte-teleconferencing kayo, or magsisynchronous class kayo. So naligo kayo. So kapag bagong gising kayo, normally pagtingin sa salamin, magulo, mataas yung kaguluhan, disorder ng buhok, for instance, tama? So the entropy, the disorderly arrangement is very, very high. High entropy. So sabi dito, the law of nature allowed to the most probable is what the system with the higher entropy. So ganito yung normal. Meron ba sa inyong natulog na nagplansya ng buhok, tapos pagkahiga, paggising, tuwid na tuwid pa rin? Baka naman wig pala. Hindi, kahit wig nagugulo. So the normal tendency, magulo talaga siya. But we can reverse that. Sabi sa second law, paano ma-reverse? Put an effort. Paano mag-put an effort? Mag-supply ka, maligo. Tama? Kahit masumay ka sa jeep, di ba? Nagugulo din yung buhok. Ano pa ba? Yellow. Oh. Again, from ice, very ordered arrangement of water molecules of solid ice. Hayaan mo lang yan dyan sa table. At sa kwarto mo, ano mangyayari dyan? Magme-melt siya. Tama ba kanina? It absorbs heat, increasing entropy. In terms of disorderliness, solid, di ba order yan? Nag-gain ng heat, magiging liquid. Mas, magiging taas yung disorderliness. Hindi na siya highly structured like solid ice. Okay? So, ganun lang siya. Can be reversed naturally from low to high disorderliness or low to high entropy. We can reverse that, but make an effort. So, kunwari, meron kayong jowa, LDR kayo. So, naturally, anong mangyayari? Magbe-break kayo. It will tear you apart. Tama? So, para hindi yung mangyari yun, ano yung gagawin mo? You have to make an effort. Tatawag ka, kahit puyat ka, te-text, or mag-video call kayo, musta ka kahit sobrang busy mo. So you have to make an effort because the natural thing in this universe is to increase its entropy, to increase disorder. Okay? Next. Yeah, do you have what the time? Mabilis na lang to kasi Faraday's and Lenz's law, it's quite fast. So you can some moment to reflect or can think of any questions you can ask before we proceed to the second topic, which is induction, electricity, and magnetism. Okay, if there's none, yeah. Now, let's proceed to the electricity and magnetism. So, katulad ng heat, hindi kasi natin siya nakikita. So, usually, kaya siya na-identified as nahihirapan yung mga estudyante kasi unlike Newtonian mechanics, kita natin yung nangyayari. But here, hindi. So, lalo na dito kasi we're pertaining to electrons. So, from your previous lectures or from previous readings or modules, what are the sources of electric field? Basta meron tayong charged particle. Alam na natin yung itsura ng electric field niyan. Merong electric field basta meron tayong charged particle. Sources of magnetic field. Pwedeng magnet, of course. An example ng magnet are Earth. It has its own magnetic field. And pwede rin namang charged particle, but the charged particle must be moving. Okay? Yung naman yung kinatin doon to get for us to have a magnetic field. So yung question na gusto nating masagot, we know that if we have an electric field, the relationship of electric field and magnetic field, so kung meron tayong charge na nagmo-move, so meron tayong magnetic field. And again, a charge itself it sets up an electric field. At ano yung relationship nila? Can be described by, yeah, you're right, the right-hand rule. So thumb will be the direction of the current or the charges. The curling of the four fingers is the direction of the magnetic field. So katulad dito, we have a moving charge, and it will generate concentric magnetic field, just like from the illustration. So ito yung, I think hanggang dito, most of the schools from high school or senior high school, natatakan nila dito eh. But most of the students, pagdating sa magnetic Faraday's law or Lenz's law, magnetic induction, dito yung electricity and magnetism, dito nila, sabi nila hindi na daw masyadong nadadaanan or hindi na napapasparan, nadadaanan pero parang reading or mabilisin na lang kasi wala ng oras. So I think, yeah, most of the students also identify this topic, lalo na yung magnetic induction, medyo magulo siya intindihin. But I think let's try to understand it better. Tapos later, baka meron tayong technique na matutunan para mas maintindihan natin yung relationship. So, question natin ngayon, kapag ba tayo ay merong magnetic field, can we, we have a magnetic field, can we have an electric field or do we have an electric field? So question, if there is an electric field, is there always a magnetic field? True or false? Siyempre, ako yung sasagot. So, if there is an electric field, is there always a magnetic field? Saan nga may electric field basta may charge? Pero may magnetic field kapag nagmo-move yung charge. So this is always true, not true, or depends. Okay. Is there an electric field? If there is an electric field, is there always a magnetic field? Hindi. Kasi pwedeng hindi nagmo-move yung charges natin. So kapag nagmo-move yung charges natin, meron pareho. Okay? Good. Question, if there is a magnetic field, is there always an electric field? So kung may magnetic field, meron ba tayong electric field? Again, we're pertaining here charges as the sources of electric field and moving charges as the sources of magnetic field. So kung meron tayong magnetic field, so kung ang source natin ay moving charge, so meron tayong charge na nagmo-move, meron tayong magnetic field. So tanong, meron ba din siyang electric field? Yes, kasi may charge tayong nagmo-move, and charge itself, moving or not, it will have an electric field. Okay? So now, during induction experiments, kung meron tayong battery, and we have switch, some iron with 2 coils, and galvanometer just to measure the current, kung merong kuryenteng dumadaan. Okay? Ano yung observations during these experiments? Kung nagawa niyo ito sa lab or sa modules nyo or napanood nyo sa video sa YouTube, and that's good. So ano yung observations? So when steady current on X, so naka-on yung switch, no current is produced in Y. So kung matagal na nang naka-on siya, meron tayong current na meron tayong naka-on yung switch, we have a steady current passing on our circuit, wala tayong nakikita o na may measure na current na napoproduce kay Y. So, sabihin, yung switch natin, papunta lang ito yung current. Steady state, sabihin, hindi siya nagbabago. So, wala tayong na-measure. Sabihin, walang current na na-measure sa Y. But, at the instant that the switch X is turned, so kapag at the very moment, the instantaneous that we switch on the switch, if we on the switch, momentarily there is a measured current in our coil Y. And also, interestingly, at the instant at which the X is turned off, switch off tayo, current is also produced in Y, but in opposite direction. Pero pagka-on, hinayaan mo siya naka-on, wala yung current. But the moment you just instantaneously on it or instantaneously off it, there is a current, but in opposite direction. So yun yung observation natin. Okay? So for instance, we have a magnet as a source of magnetic fields. Meron tayong loop of wires. Meron tayong galvanometer or ammeter to measure the current. So current from the readings, makita natin, current is only present through the coil when the magnet is moving toward or away the coil. But when it is just stationary, wala tayong na-measure na current. There's no induced current. So Faraday's law, again, from the statement, the induced EMF or induced voltage in a closed loop is equal to the negative of the time rate of change of magnetic flux through the loop. Ano daw? So in simple equation, ito siya where epsilon is the induced EMF, the induced voltage kay X or kay Y, dun kay Y, or from the loop and from the magnet. So we have the induced voltage at the magnet, at the loop is equivalent to the negative of the time rate. Actually, it's redundant, but the rate is the change in time of the magnetic flux through the loop. So again, no induced EMF if the flux is constant. If the flux is not changing through time, hindi wala tayong measure. So it must be changing the flux, the magnetic flux. So induced EMF in a curl or coil with n turns, where n is the number of turns. So it's equivalent to this equation, or it's equivalent to the change in the magnetic field times the cross-sectional area and phi, cosine phi, where phi is the angle between the direction of the magnetic field and the cross-sectional area, can induce EMF using this equation. But as we recall, ano nga ulit ang magnetic flux? It's just the amount of magnetic field lines passing through a surface area, cross-sectional surface area. So yung first illustration, flux is proportional to the density of the flow. So we have a certain constant surface area of the circle. Kung lakasan natin yung magnet natin, so mas madaming magnetic field lines yung pumapasok dun sa ating cross-sectional area, mas mataas ang flux. So ngayon, same lang yung flux. Paano ko naman yung i-tilt natin ng konti? Cosine phi. Again, phi here is the angle difference between the magnetic field lines, ito yung red lines, and the plane of the surface area. So with that, flux varies by the boundary phases in the direction of the flow. So dito sa kanan, we have ilan, bilangin natin kung ilan yung magnetic field lines. 2, 4, 6. So we can just briefly describe there are 6 magnetic field lines. Kapag tinilt natin ng content sa the figure, kumonte. So humina yung flux. Okay? Or pwede rin natin baguhin ng cross-sectional area. Paliitin natin, squeeze natin. From this original, squeeze natin siya, paliitin. Umunti yung number of magnetic field lines passing through the cross-sectional area. Kasi lumiit yung cross-sectional area. Thus, we are changing also the flux. Okay? So as an example, example again, a single loop of wire with an area of 0.09 meters squared in a uniform magnetic field that has an initial value of 3.8 Tesla is perpendicular to the plane of the loop and is decreasing at a constant rate of 0.190 Tesla per second. The question is what EMF is induced in this loop, and if the loop has a resistance of 6 ohms, find the current induced in the loop. Okay, so what is the first question? What EMF is induced in the loop? So the changing magnetic field causes the changing magnetic flux through the loop. And this induces an EMF in the loop, which causes, again, the current flow in it. So this is our equation. And we know that flux is equivalent to the magnetic field times cross-sectional area cosine phi. Where here phi is 0 since there are. Bakit phi equals 0? Ano ba yung problem natin? Okay? Okay. A is constant and B is changing. So here the cross-sectional area, if it is constant, but the magnetic field strength, the magnetic field is changing. So we have A d B dt. Again, since this is constant. Oops. So just plug in the cross-sectional area is given. We have the rate is also given, which is 0.19 Tesla per second. And we can have 0.0171 volts. So given the change in magnetic field on a constant surface area, so it will produce or induce a voltage of 0.0171 volts. So if the loop has a resistance of 0.6 ohm, what will be the current induced in the loop? V equals to IR, Ohm's law. So we have here 0.0171 volts over 0.6 ohms. So just some direct substitution and problems. Okay, so now we have the Lenz's law. So an induced EMF is always in a direction that opposes the original change in flux that caused it. So actually, Faraday's law states that the induced EMF is caused by the changing flux in time. Si Lenz's law, sabi niya, itong induced EMF na to, ino-oppose yung changing magnetic flux in time. So kung opposing in terms of vector, it's negative. So kaya negative siya. So yun yung ambag ni Lenz's law natin. So kunwari, meron naman tayong source ng magnet. So we have here north and the south pole. Anong itsura ng magnetic field sa north, closer to the north pole, palabas siya ng north pole. Tama ba? Palabas ang north pole, papasok sa south pole. So we have a coil. So velocity, we're moving the magnet towards the loop. Okay, so we can state that, we can identify that we are increasing the magnetic flux on the ring with be directed to the right. Bakit we're increasing? Since nilalapit natin yung North Pole. Kasi if we are to visualize the magnetic field lines produced by magnet, diba, mas mataas, mas dense yung magnetic field lines, mas dikit-dikit yung magnetic field lines, katulad dun sa illustration natin sa magnetic flux, mas mataas yung magnetic field. So habang nilalapit natin yung magnet, nag-i-increase yung magnetic flux as seen from the loop. Tama? Kasi nilalapit natin siya. And with here, the induced EMF, sabi, the induced EMF is always in the direction that opposes the original change in flux that caused it. So ano yung original change in flux? It is increasing towards the loop. Tama ba? Kasi nilalapit natin, nag-i-increase yung magnetic flux habang nilalapit natin ay yung direction to the right. Tama? Or towards the loop. Tama? So ano yung direction ng induced EMF? Dapat ino-oppose niya yung pag-increase to the right. So the EMF should be, the magnetic field that caused this induced EMF should be towards to the left. So from the right-hand rule, if it's towards to the left, anong direction ng ating induced current? Oops. As seen from the magnet, it is counterclockwise. Right? So yeah, point to the left. Next, paano naman kung same magnet pero nilalayo natin siya? So habang nilalayo yung magnet, we're expecting the magnetic flux or the number of magnetic field lines passing through the cross-section area decreases. So we have, a decreasing magnetic flux through time. So kung meron tayong decreasing magnetic flux through time, paano natin manenegate yung effect niya? Kasi sabi sa Faraday's and Lenz's law, the induced EMF must oppose, kaya nga siya negative, the change in flux. So if it is decreasing to the right, dapat it is, that's right, increasing to the right. Kasi nababawasan ng pakanan. So para somehow ma-compensate o mabaliwala yung change, dapat bawasan din, dagdagan pakanan. Tama? So the induced magnetic field on the loop is to the right, and from the right-hand rule, the direction of the current is clockwise as seen from the magnet. Okay, so decreasing magnetic flux on the ring to the right would be directed to the right, and the induced magnetic field should point towards to the right to compensate the change of the original flux. Now, okay, so now can you try this? So we have 4 different magnets and loops. So yeah, can you try solving this one? So maybe I can quickly change so that I can show you some of the solutions. So meron tayong magnet, south pole naman, yung nakaturo dun sa loop. It is moving upward. Meron tayong moving downward. And later, let's try if I can give you some technique on how to do it. Okay? Let me change for a while. Okay. Okay, yeah. So now let's try to answer this. So the first, again, we have a magnet And the magnet is, the south pole of the magnet is the original magnetic field. Anong itsura ng magnetic field ng south pole? Papasok sa kanya, tama? So meron tayong magnetic field. Papasok sa kanya. This is the magnetic field of the south pole, tama? So kung yung magnetic field ng south pole ay palayo, so it is decreasing. Tama ba? Decreasing siya, no? So kung meron tayong original magnetic field na decreasing upward, ano dapat yung ma-induce na magnetic field para ma-compensate? Kasi sabi dun sa equation natin, ito, negative. The induced EMF should compensate somehow on the direction opposite to the change in the original magnetic flux. If the original magnetic flux is decreasing upward, so dapat yung induced magnetic field on the ring should be increasing upward. That's right. So dapat the induced magnetic field. So ano yung induced current na magpo-produce ng upward magnetic field from right-hand rule? So as seen from the top or from the magnet, it is counterclockwise. Tama ba? Ito yung ating induced current. Nakuha? So here, yeah. So another example. So paano kung meron tayong south pole? So again, anong itsura ng magnetic field ng ating source of source ng ating magnetic field? South pole papunta sa kanya. Inward. So this is the original magnetic field. Since the motion of the magnet is towards the loop, so increasing, decreasing. So it is increasing. Okay. So kung increasing yung original magnetic flux natin, ang direction ay pataas, so the induced magnetic field should be increasing at what direction? Increasing pataas. So kailangan kontrahin na yun. It must increase downwards. So this is the induced magnetic field. At ano yung induced current na magpo-produce ng pababang magnetic field? From right-hand rule, as seen from the magnet, it is clockwise. Okay? So pero, meron dyang, actually turo pa sa akin to nung friend ko nung college. So ito, sabi nila, alam natin na same poles will repel each other and opposite poles will attract each other. Tama? So kunwari, meron kang, same example, meron kang south pole, north pole. Ito yung green natin and the motion is away. Okay? So kunwari, meron kang south pole na lumalayo. So kung meron kang nililigawan, kapag lumalayo yung nanliligaw sa inyo, ano yung gusto nyong gawin? Siyempre, gusto nyong palapitin. Ano kayo, di ba? Parang gusto nyong gumawa ng some steps. Bakit hindi na siya nangungulit ngayon? Bakit hindi na siya nagpaparamdam? So gusto nyo siyang palapitin. Tama? So kung meron kang south pole na lumalayo, para siya mapalapit, ano yung kailangan mo? Para ma-attract yung south pole, kailangan mo ng another north pole. So parang pwede mo siyang isipin na meron kang north pole dito. Okay? Para lumapit siya. At anong itsura ng magnetic field ng north pole? Palabas, pataas. So ito yung magnetic field lines ng induced magnetic field mo. At ano yung direction ng induced magnetic field kapag upward? Counterclockwise. Diba? So parang, isipin nyo lang na parang ganun yung analogy natin. So ito, dito, so kung meron kang south pole ulit, north, lumalapit naman. So ngayon, kinulit nyo na yung nanliligaw sa inyo, tapos palapit na siya. So pag palapit naman, nairita naman kayo na, ang clingy naman, ito gusto mo siyang palayuin. So yung loop, para mapalayo, parang pwede siyang mag-act as para mapapalayo ang south pole, kailangan mo ng another south pole. South pole. So kung south pole, anong itsura ng magnetic field lines ang south pole, papasok sa kanya. Tama? Oops. Baguhin na lang natin yung color. Ayan. Ito ang magnetic field induced. on our loop. So anong itsura ng magnetic field? Ang induced current from a magnetic field pointing downward, as seen from the magnet, it is clockwise. So same. Diba? So para mas madali yung ating analysis. Kasi dito, yan, isipin nyo pa from the original, isipin mo ba from the original magnetic field, ano yung behavior? Increasing, decreasing. Ano yung direction? Away or towards, upward or downward. Tapos analyze mo pa kung increasing siya, so kailangan yung induced magnetic field must negate that increasing magnetic field. In what direction? Isipin mo pa ulit. So dito, at least mas direct, mas straightforward yung ating analysis. So kunwari ito, sige nga, apply natin. So meron kang North Pole na lumalayo. So kung lumalayo ng liligaw sa inyo, gusto mo siyang palapitin, gawin mo itong south. Kung south to, anong itsura ng magnetic field ng south? Papunta sa kanya. So ito na yung induced magnetic field mo on the loop. So ang induced magnetic field mo ay downwards. Ang induced current mo should be clockwise. Tama? Which is seen on our previous, nasagutan na natin ito kanina. Almost the same dito. Okay? So last example, ito na yung last. So, meron kang North Pole na lumalapit. So, kapag lumalapit, ang nanliligaw, gusto mong palayuin. Paano siya lalayo? Kung north siya, kailangan mo ng isa pang north. Tama? Anong itsura ng magnetic field na yun sa north? Palabas sa kanya. This will be the magnetic field induced, upward, palabas, counterclockwise. Oops. Tama ba? Okay. So now, let's have some other examples. So para mas practice, so try nyo sagutan. Last na to, I think I have like just 2 questions, some examples. So a circular loop of wire in the region of spatially uniform magnetic field. So kapag X, ano yung direction? Into the page or into the screen, right? So the magnetic field is directed into the plane of the figure and determine the direction, clockwise or counterclockwise, of the induced current in the loop when, first, magnetic field is increasing. Okay. If we have a magnetic field increasing towards the plane of the loop, so same analysis lang din, increasing pa paloob. Gusto mo siya, sabi nila sa law, kailangan i-negate mo yung change in flux. So kung increasing paloob, you have to increase outward. Tama ba? So for A, so the magnetic field should be, the induced magnetic field should be increasing upward. Kung increasing upward, anong itsura ng, anong direction ating induced current? Clockwise or counterclockwise? This is, para kung ano yung sumasayaw kay Bayani. Ano to? Counterclockwise, sorry. So counterclockwise. Pag ganito yung ating induced current. So for B, decreasing. Kung decreasing naman, pababa. So para makompensate yung pag-unti ng magnetic field lines pababa, kailangan tayong mag-increase pababa. Tama ba? So in B, the induced magnetic field should be increasing towards the loop. Kung towards the loop, anong direction ng ating induced current? Clockwise or counterclockwise? That's right, clockwise. Induced. Yan. B is constant. Ano kaya kapag B is constant? There's no change in flux, 0. Tama ba? Counterclockwise. Okay, ito yung solution. Okay, tama tayo. Counterclockwise. Letter B, clockwise. Okay, tama. And letter C, no induced current. Again, bakit no induced current? Because B naught is the magnetic field lines passing through the cross-section area is constant, the flux is constant. No change of flux in time. So kung I squeeze the ring, lumiit momentarily dun sa pagliit ng cross-sectional area, bababa yung flux, there will be an induced current. Tama? Kung in-stretch ko siya, magbabago rin yung number of magnetic field lines or the flux passing through the cross-sectional area, magkakaroon tayo. Okay? Meron pa pala. May quiz pa. Okay, anyway, so let's just answer this. Last na talaga to. A flat rectangular coil of dimensions L and W is pulled with uniform speed through a uniform magnetic field with a plane of its area perpendicular to the field. First, find the EMF induced in the coil. Sige nga. So meron kang loop, hinihila mo siya at constant velocity in the uniform field and in direction out of the page. Find the EMF induced in the coil. Ano yung EMF induced by the coil? The induced is, that's right, it's zero. Ah, talaga? Bakit zero? Zero ba? Tama ba ako? Tingnan nga natin. Bakit just zero? It's because the flux is constant, and in this case, the induced EMF will be zero. There will be no induced EMF. If the speed of the magnetic field, if the speed of the magnetic field are both tripled, so kunwari, yung speed nung paghila natin pa kanan, nung loop, bilisan natin, but still constant, magbabago ba yung number of magnetic field lines passing through the cross-sectional area? Hindi pa rin. Taasan natin yung magnetic field strength or the number of magnetic field lines passing through the loop. Again, tinaasan natin na hindi yung we just switch. After switching, mataas, mas madami yung magnetic field lines, but still, it's not changing. Therefore, the induced magnetic field is zero. Ah, meron pa pala. Sorry, last na pala to. Last na talaga, swear. The current in the figure obeys the equation with this. So, ano yung behavior nito? Huwag tayong ma-intimidate sa mga EE na ganyan. E to the negative, so 1 over e to the minus. So, exponential yung behavior. Since negative, exponential drop, where b is greater than 0. So, find the directional clockwise or counterclockwise of the current induced in the round coil for t greater than 0. So kung meron tayong current passing through to the left, so anong itsura ng magnetic field niya? The external magnetic field, so dito ay, tama ba? Papasok dito. Tapos, palabas dito. Tama? Papasok sa taas, palabas sa baba. So kung ito yung itsura ng ating magnetic field, yan, sige. Kunwari, maganda na lang yung drawing ko. Ayan ko. Okay. And the current decreases its value. So what do we expect dun sa magnetic field? Nagbabago din. So can we say that the flux is changing? Yes, kasi nagbabago yung current natin through time. Tama ba? It's exponential. Decreasing. So kung meron tayong decreasing magnetic field experienced by the loop, ano yung magnetic field experienced by the loop? It is into the page na decreasing. So kailangan yung induced magnetic field must be, that's right, also increasing into the page. Tama? It is the, again, madami siya. Hindi ko na lang i-drawing. Ayan. This is the induced. It is increasing into the page. At anong itsura ng current kapag we have induced magnetic field into the page? We have a clockwise induced current. So this is the induced current. Sorry sa aking magulong drawing, but essentially, yeah. Yeah. Tama? So here, outward. Sorry. Yeah, it's outward. Outward. Hindi pala counterclockwise. Since it's outward, so sorry, outward. Kung outward yung current natin, ano yung, ito, counterclockwise pala to. Sorry. So ito ay counterclockwise. Tama? The induced magnetic field kapag tuldok, it's out. Tapos, then it will have counterclockwise. Tama na ba? Yeah, we have counterclockwise. Okay? So I think that ends my presentation. So yeah, I hope I've shared something that most of you are getting confused into. So yeah, thank you very much again.
Thank you so much po, Sir Dustin, for sharing us with your experiences and tips and strategies in physics. So, to our dear participants, if you have questions, you may raise them at this moment po um, sa ating comment section po sa Facebook Live. So, do we have any questions po from our participants that you wish to ask our speaker? Okay, so Sir Dustin, almost everyone here is thanking you po sa ating for sharing us with your lessons learned po dito po sa physics po. So ako po personally, as a DevCom graduate, I was able to learn a lot po tungkol sa physics and recall po some of my high school lessons in physics, mas lalo na yung sa thermodynamics. Naalala ko, I think, bagsak ako dun sa exam na yun eh. So, siguro kung naka-attend ako ng webinar na ito before, siguro napasa ko yung exam ko na yun. So, anyway, do we have questions from our participants, our students? So, I guess, walang may mga questions. Siguro po, Sir Dustin, ano po yung final tips or words of advice nyo po for our students that you could share to them po, especially those who are taking up physics classes po this semester and the succeeding semesters po?
Hello? Narinig ba ako?
Yes po, sir.
Okay, sorry. Nagpalit lang ako ng earphone. So yeah, siguro tips. So wag tayong magpaka-stress dahil syempre alam natin ngayon stressful yung situations natin plus hindi tayo no? So parang let's take this opportunity to understand our learning styles at para kung sa ganun kahit sino yung teacher natin, kahit ano yung klase ng mode of learning natin, virtual man yan or kapag bumalik na yung face-to-face. So hindi tayo maging dependent sa external factors just like our teachers or the way our teacher teaches us or with the manuals or with the modules that we have. So I think we can use this time to enrich ourselves para mas mag-adapt sa mga different learning environments. At by that, I think kahit hindi lang sa physics, you will that skill will be very helpful for students to learn and cope up new different topics. It might be hard, it might be during their thesis, it might be during while they are working. So I think that's the main, not just physics per se, but I think the concept behind is just training yourselves and developing yourselves to cope sa mga ganitong difficult situations. I think that could be a good takeaway for everyone sa ating mga.
Thank you po, Sir Dustin, for your words of advice. And I think we have a question here po from Renz Vergara. Ang tanong niya po is, Sir, can you explain further po the concept of a room with an air conditioning unit and an open window?
Air conditioning.
So I think dito po ata papasok yung, lalabas ang lamig, parang ganun po.
Yeah, okay. I see. Yeah, so normally sasabihin, naku, lalabas ang saraduhan ng pinto o saraduhan ang bintana kasi lalabas ang lamig. But as we all know, paano nagmo-move ulit ang heat, how heat transfers from higher temperature to lower temperature. So ano yung mas tama? So kapag bukas yung pinto, bukas yung bintana, papasok yung init. So mahihirapan yung ating aircon, yung ating AC na palamigin yung loob kapag mas maraming init yung pumapasok. So that's the more, I think, the more technical proper term for that. So hindi yung lalabas yung lamig. No? Yeah, thank you for that question.
Thank you po, Sir Dustin. So, sir, we have participants who are asking if they could have a copy of your presentation po.
Actually, my presentation, the slides, the content are in the book. So essentially, I think you can just read like University Physics book. London siya. Actually, yung mga illustrations, nandun silang lahat. So wala namang bago dun sa sinabi ko aside from the sharing of my experiences. But essentially, all the content, physics is physics, hindi naman siya nagbago, yung electricity and magnetism and thermodynamics. So yan, basa lang tayo or again, kung mahihirapan pa rin, meron tayong mga crash courses, sobrang helpful. Personally, doon ako medyo nag-survive dun sa mga uh, virtual learning natin na nood tayo ng YouTube videos. Helpful din sila, sa totoo lang.
Sir, paano pala po kung may mga gusto pong mag-consult po sa inyo? Could they reach you through email po?
Oh yeah, sure. Yeah, maybe sa PubMat, nandun ba yung email ko?
Wala pa po.
Wala
Wala
na.
pa
So,
pa, sir.
siguro we can, maybe you can share like the email address so
Sige
that
pa.
they can contact me, they can reach out to me. Yeah.
Okay pa, Sir Dustin. So, thank you po once again po for your valuable time early in the morning.
Yeah.
Diyan po sa Canada. So, at this point, we will be awarding the Certificate of Appreciation to our distinguished resource speakers. So, may I call on our beloved director, Ma'am Benji Flor, to award the certificate. So, let me read the citation. University of the Philippines, Los Baños, Office of the Vice Chancellor for Academic Affairs, Learning Resource Center, presents the Certificate of Appreciation to Dustin Loren Almanza for serving as resource speaker in the webinar Let's Get Physical, a webinar on appreciating concepts in physics, held on December 4, 2020, given this 4th day of December 2020 at the Learning Resource Center, UPLB College, Laguna. Signed, Benjamina Paula G. Flor, LRC Director.
Thank you so much, Sir Dustin. So I hope we did not disturb you so much. I just got to Canada, and I hope our students. I saw some of the comments, and they were so grateful that you were able to share to them complex concepts that are now more understandable. So I hope they're able to appreciate. And it's only now that I also appreciated my son, who is a graduate of applied physics.
Oh.
And so he's now in Arizona working for a semiconductor company. So now I understand how difficult physics is, but how practical is as well. So I hope we all understand how physics would propel our lives and how this can be understood well and applied in a practical sense. But I guess all these subjects, that's why students were asking for these subjects for tutorials, because of the difficulty in terms of understanding some of the concepts, especially the application. Kay Sir Dustin, very, very practical yung mga applications. Pag may nagustuhan ka at lalayo, paano mo mag-attract, baka naman ang maisip din nyo ay kung paano mag-attract ng inyong gusto. Yung mga computation ng mga negative poles and positive poles. Just the same, you were able to make them, or you were able to laymannize or at least simplified some of these concepts that may appear alien maybe to many of us, but of course to physicists this could perhaps be something that's just a review. But I guess our students who are in right now are really wanting to have some basic understanding of these principles. And with that, thank you so much for gracing this invitation, and we hope that we could invite you again.
My pleasure.
Sometime soon. And good luck to your PhD in
Thank you po. Thank you po. Until next time po. Thank you to LRC. Thank you.
Thank you so much po, Ma'am Benj. So, noted po yun, Sir Dustin. So, hopefully po kunin po ulit namin kayo na speakers in our tutorials po. Maybe in the succeeding succeeding semesters po. So at this point, before we end our program, Konting reminders lang po. So our participants, please do not forget to answer the evaluation form, which will be sent only to registered participants for this webinar. So the deadline for answering the evaluation form is until 12 o'clock midnight tonight. So you have until then to secure your e-certificate of participation. Okay? So at this point, I would like to thank our team hashtag Team LRC, headed by our director, Dr. Benji Flor, with our webinar director and the director of the Office of Public Relations in UPLB, Prof. Mark Lester M. Chico, our University Extension Associate, Ms. Cheryl Ed P. Hermosa Ebron, Ms. Annalyn Mangente, our administrative aide, and Kuya Iwak Balatian, our junior utility worker. Without them po, these events would not be made possible. So mga iskot iska, just a few parting words. It's very much okay to ask for help in your studies because each one of you learns continuously and at different paces. And of course, because each one of you is uniquely intelligent. Again, no topic is too hard for a student with a positive mindset and a persisting dedication to learning. With a little hard work and determination, you can easily ace your subjects here in UP and in other universities. At LRC, we are very much honored to continuously serve you in these academic support programs because we firmly believe that together we can achieve academic excellence. Thank you and have a pleasant evening to all of you.